find the area of the unshaded region of the circle with radius 6 units here. So number 5. It's number 4, right? Yeah. Okay. And then I'm going to use my circle tool to kind of draw this this kind of area for you out. So let's see. I have a diagram here. It's asking me, I have some point of A, O, and B, right? So I'm going to say this is here as a center. So I have some point of A, some point of O, which is a center, some point of B here. And I have some sort of angle, and it's going to equal 120. So let me just draw this out. So this angle theta is going to give me 120 degrees. And I want to find, and this radius here is 6, right? So between AO, this here is 6. Maybe on black ends. So here's 6 meters, and this is 120 degrees. And I want to find the area of the shaded area. So we can say that this here is our shaded area, right? This here is our shaded area. So how do we find this area here? So in order for us to find this area here, what we're going to have to do is we're going to have to basically take the area of a circle, right? So we know the area of a circle here equals pi r squared, right? Normally. So an area of an entire circle is pi r squared, right? And this is a good starting point for how we figure out our solution, right? So here, the area of a circle, or in this case, if it was the entire circle, 360 degrees here, would equal pi r squared, right? However, I'm only looking at this shaded region here. So what percent of the circle would this make up? And I would have to look at this percent, and then I would have to look at this here and modify our formula here. So I have 120, right? 120 degrees here, and in a circle I have 360 degrees, right? So in circle, it equals 360 degrees, and currently I only have 120 degrees, right? So this here is, therefore, this here, I can safely say that this here is 1/3 of my circle, right? Because I could have another angle that would be another 120 degrees. So if I were to look at it, it'd be something like, this maybe. I don't know. It's hard to visualize here just because I can't really cut this up in like 3 angles. I would probably have to. It'd be something like here. It'd be a line like this, and this is 1/3. This is 1/3, and this is 1/3. And although it's not accurate, here. It's not to scale here. These are supposed to be equivalent numbers, equivalent values here. So in a circle, it's 360 degrees. So if my shaded region is only 120 degrees, it's simply just 1/3, right? It's simply 1/3. So I can simply do 120 degrees by 360 degrees, and this here simplifies to 1/3. And this here is our magic ratio for us to change our formula, right? So therefore, I can say that area of the shaded region here, so I'm going to say area of the shaded region for S here would equal 1/3 pi r squared, right? Because it's 1/3 of the circle here. And now we can simply solve this problem here, right? My radius here is 6, so I can say that this here equals 1/3 times pi times 6 squared. 1/3 times pi times 6 squared is 36. And then I can say 1/3 times pi here, or sorry, 1/3 times 36 here is simply just 12, right? So the area of the shaded region here is simply 12 pi. And this here is the correct solution. Or sorry, I want the unshaded region. Oh, I messed up. So, okay, that's fine here. So this here is the area of the shaded region. So this is the shaded region. So therefore, the area of the unshaded region, would equal the total area minus the area of the shaded region, obviously, right? And I know the total area here is simply just pi r squared, right? If it was the entire circle here. So let me just do some side work here. So area of the entire circle is just A equals pi r squared, pi times 6 squared here, which is simply just 36 pi, right? Pi r squared. So I can simply subtract 36 pi from 12 pi to get to my answers here. So area of the unshaded, which is what I want here, area of the unshaded region, right, is equal to the area total area here, which is 36 pi So here's 36 pi minus the area of the shaded region here, which is simply 12 pi. So area of the unshaded region is simply just 24 pi square units. So this here is my solution for this problem here, 24 pi. And as you can see, they did the exact same thing. So they found out the area of the shaded region, and then it's going to add up to the area of the unshaded region to give me the area of the full circle. So solution here is correct. Go to analysis here.